title, Module 2, Basics of Database Management System. Yeah, so we need to learn some more basic concepts. Yeah. Part A, more on databases and DBMSs. Yeah. 8.1, advanced features of DBMSs. Yeah. In this part, we will learn 3 advanced features. Yeah. All right. Before we start our first advanced feature, let me explain one SQL query we did last time. Okay. Yeah. So there are some, several important points I need to explain. Yeah. All right. So let's recall we did this example last time. Yeah. Let me. Yeah. All right. Yeah, this one. Okay. Yeah. So here we use the feature MySQL limit clause feature. Yeah. We use this feature. Yeah. All right. In this select statement, yeah, after the condition, where clause. So after this condition, yeah. Still, when we execute this query statement, we get a large number of rows in the query result. Yeah. So we want to see part of it. Okay. Sometimes we do not want to see all the rows in the query result. Yeah, so MySQL allows us to do that using this limit clause. Limit, yeah. Limit, then there are 2 parameters here. Yeah, 2 parameters. Yeah. Here, let me explain the meaning of these 2 parameters. Yeah. Second parameter, the meaning is clear. Yeah. Second parameter, this 20, we need to display 20 rows. Yeah. Total number of rows to be displayed, 20 rows. Yeah, that's easy to understand. The first parameter, yeah, so a little, we need to explain a little more. Yeah. The first parameter, it's called offset. The meaning of the first parameter is the offset. Yeah. So we need to understand the meaning of offset. Yeah. All right. So let us consider a typical query result. Okay. All right. So think about if we do not apply this limit clause. Okay. Yeah. Yeah. We just run the query statement before this limit clause. So you can imagine the query result contains a list of rows. Yeah. All right. Then after that, we apply this limit clause. All right. When you apply, you need to specify which row you want to start as your first row to display. You need to specify the first row. Yeah. So this offset is used to specify the first row, location of the first row. All right. So suppose we define the number of rows in this many as the offset. All right. Yeah. Then the first row to display, that's the row after this offset number. Okay. Yeah. Below this offset number. All right. So here there are 1,000 rows in the offset. Then you skip 1,000 rows. First 1,000 rows. That's the meaning. You skip the first 1,000 rows. Then you display your first row. Okay. All right. So after that, then the second parameter, number of rows, number of consecutive rows. All right. Yeah. So that's these two parameters. All right, yeah. So then, after this version, there is a default version. Yeah, because here the offset, you need to specify the offset, but there is a default case for the offset. Default case. So you use the limit. You do not specify the offset, okay? Yeah, because there is a default offset. Default offset equals 0, okay? So default offset equals 0, okay? Yeah. So then you, for example, you put 10, okay? Limit 10, yeah. This means you only display the 10 rows, yeah, with default offset 0, yeah. But you skip that 0. 0 means, so you skip 0 rows. That means you display the first row. So you start from the first row, and then you display 10 rows. So in that case, you do not need to write this 0 out. Okay, you just use one parameter, limit 10. Yeah. All right. So then, based on that, because sometimes people want to display some one row with the highest number, right? Yeah, one row with the highest number. Okay, yeah. So for example, display one row with highest or largest number for one field. In this case, okay? In this case, yeah. First, you need to sort this row with respect to the field. Okay? Yeah. For example, here, let's modify. Let's modify this statement. Okay. First, I keep the the first part. Okay. All right. Then, actually, I do not need to keep everything. Yeah. Let me just select start from order detail. Details. Then I want to sort it, okay, based on the quantity. Okay, quantity. Yeah. We use another clause called order by. Order by. Yeah. Order by quantity. But order by quantity, when you sort it, do you want ascending order or descending order? Okay, yeah, when you do order by, there are two cases: ascending order and descending order. Ascending order is the default case. Okay, yeah. So if you do not say ascending or descending, yeah, so by default that's the ascending order. But we want to select the row with the largest quantity. Okay, that should be the descending order, right? Here descending order, so you need to specify DESC means the descending order. Okay, then after that, because we only take one row with the largest quantity, so we can add this limit 1. That's it. Okay, limit 1. Yeah, yeah, yeah. Because we, that offset is 0. Yeah, we only take the first row, so limit 1. Yeah. Okay. All right. Yeah. So here you can see, several ways, different ways we use this limit clause. Then another thing I also need to explain. I mentioned a little bit, but last time I didn't have enough time, so I couldn't explain more. In this statement, okay, this simple statement, you can see some words we use capital letters, right? Capital. Some words we use lower cases, right? Yeah. So here, I want to explain. Yeah. So why people commonly use the capital uppercase for the SQL keywords. Okay. Here you can see when we write SQL keywords, most of the time we use uppercase. Yeah. And it is not required. Okay. It is not required. So it's by convention, okay? By convention. Yeah. All right. Yeah. So for programmers in this community, by convention, people use uppercase for the SQL keywords. Yeah. If it's a non-SQL keyword, then you do not need to take this convention. For example, order detail, this is the table name. Quantity, that's the field name. They are not SQL keywords. Okay, so you can use their original form. Yeah. And why, by convention, people use uppercase? The main reason is for readability. Okay, for readability. Yeah. So uppercase, lowercase, you can see the clear difference. Yeah. Mainly for the readability. Yeah. But it is legal use lowercase case. Yeah. And actually, if you read some technical articles online, sometimes you can see the authors use lower cases to write SQL keywords. Yeah. And yeah, so just let you know this point. Okay. All right. Yeah. So then we start our first advanced feature, transaction in DBMS. This concept, this transaction, it's in database context, its meaning is different from our everyday life transaction, general transaction. Yeah? Yeah. It has its specific meaning. Yeah. So here, let me explain. Yeah. This concept important. Yeah. All right. What's the definition of transaction in the database context? Yeah. Define a business task containing a sequence of database accesses that cannot be separated. Yeah. So this one sentence explains why people use this concept. Yeah. All right. So let me explain several points in this sentence. Yeah. First, in business, people need to do some specific business tasks, right? Yeah. So let's imagine some business task. In order to complete this business task, you may need to do a sequence of database queries, a sequence of database accesses or queries. Okay, all right. Yeah. And another important condition, when you run this sequence of database queries, you cannot split them. You have to run from beginning to end without pause. Okay? Yeah. So you cannot, from beginning to the end continuously. Okay? Without interruption. Without interruption. Yeah. If it is interrupted, then some severe problem could occur for your business task. Yeah. That's the main consideration in business. Yeah. If for some reason you couldn't complete, you have to stop somewhere in the middle, then your data could be messed up, right? Yeah, because in this business task, you need to work on some critical data, business data, right? Yeah. But if the sequence of queries is interrupted, okay? If the execution of this sequence of queries is interrupted, then your data could be messed up, corrupted. Yeah. So some severe problem could occur. Yeah. For that reason. Yeah. So the business people, so they want some technique built in the DBMS to prevent things like this happen. Yeah. So then this transaction concept is created to protect this group of database queries, such that its execution must run smoothly without interruption. Yeah. That's the main consideration here. Okay. All right. Here, let me give you a simple example. Yeah. You can imagine the real world situation, but here I use a very simple example: a sequence of banking transactions. Okay. Yeah. And in a banking transaction, we know we need to withdraw money from account A. Yeah. So so then deposit the money in account B. Yeah. So then we complete one transaction. Okay. So this transaction requires these two queries. So you can, withdraw and deposit. Yeah. All right. But if some problem, it could be technical problem, or could be natural disaster, tornado, earthquake, volcano, a lot of real world problem that may cause the interruption. Okay. Yeah. So between these two queries, no separation is allowed. Yeah. Otherwise, after you retrieve the money, but you couldn't make a deposit immediately in account B, then something big occur in the middle, right? So then the money, total amount of money may not, so it could be some problem, okay, in the total amount. Yeah. So for that reason or consideration, yeah, so you really need to build some mechanism to protect this sequence of queries. Okay. Yeah. All right. So then in the DBMS, so in the modern relational DBMS, yeah, so you must have this feature, this advanced feature. Yeah. All right. Yeah. So how to do it, right? Yeah. Yeah. So now, after you know the importance of this concept, next questions: how to implement transaction inside the DBMS, the main idea. Yeah. So here, let me describe the main idea. Yeah. There are several steps. Yeah. All right. The first step, you need to define the starting point of a transaction. Okay, a transaction contains a sequence of queries. Yeah, 1, 2, 3. A sequence of queries. Okay, yeah. You list them. Okay, all right. But in this list, yeah, this whole group is treated as integrated task. All right, yeah. But you need to tell the DBMS what is the starting point. Okay, you start from this line. All right, the starting point of your transaction. All right, yeah. All right. After that, following that starting point, yeah. Following that starting point, yeah. Then you can list all the queries in that transaction. All right. After that, commit the transaction. Yeah. What is the end point? Yeah. But you have starting point, then you need to tell the end point. Yeah. End point. So you do not need to say this is the end point. Yeah. Because you. Yeah. Here. You do not. So starting point. Yeah. Starting point in Java. Java people use transaction.begin. Yeah. So first you need to. So here let me give you an example in Java. Okay. In Java, first you need to have a transaction. You need to create a transaction object. Okay. Yeah. Some transaction object. This object has a begin method. Dot begin. You call begin method. That means you start this transaction. Okay. After that, you do a list of queries. Yeah. Then at the end, you need to commit. Yeah. Commit. End means you commit. You call it one command is called commit. Commit command. You call it. Yeah. Then the definition. Yeah, because all the queries between these two lines treated as the whole transaction. Yeah. All right. Then after that, you need another important step. Yeah. Because something could happen between, right? Between the starting point and the end point, something could happen in between. So you need to do something. If something is wrong in between, then you need to do some, damage control, right? Damage control. You do not want to make any damage on your data, on your critical business data, right? So the last step, roll back if there is an error. Okay, roll back. You need to write the rollback code. Okay, all right. Rollback. That means the DBMS does not execute. Roll back. Okay, roll back to the point before the starting point. Okay, roll back. Yeah. So you tell the DBMS roll back before the starting point. Yeah, and in this rollback block, okay, yeah, you can write some cleanup code. Yeah, when you reach this, something is wrong in Java. There is exception, right? Throw exception. Yeah, and if exception is thrown, then you get to this, rollback code block. Then you need to write some cleanup code. When you have rollback, you need to, do some damage control work. Yeah. But, the execution roll back to the, before the starting point. Yeah. Now you may ask, how can you do that, right? Yeah, I believe some of you, because when you execute some commands, how can you roll back, right? Yeah, so that's an important question. Yeah, actually, in the DBMS, before you call the commit, it does not execute any command. Okay, it does not execute any queries in between. Yeah. No execution before you call this commit. Okay, it just put them in a queue and prepare all the queries and get them ready. Get all these query commands ready for the execution, but they do not execute. Okay. After you hit this commit line, then the DBMS execute all the commands all together, okay, without interruption. Yeah. Because that execution from beginning end, you already get it prepared, okay, get it ready, okay, execute that from beginning end. Yeah. Then before commit, some problem occurred before the commit line, yeah, because those lines have not been executed, right? Yeah, before the commit line, that means all those queries have not been executed. That's why, DBMS can roll back before the starting point line. Okay, yeah. So that in that way, okay, yeah. All right. Yeah, so this is a very important transaction. After you understand this concept, later in your real world applications, many times you need to put a set of related database queries in one transaction. A set of, and actually, here I can give you a Java example. In Java, it's JDBC technology can handle transaction. Java has, JDBC technology can support, this transaction. Okay, yeah. But other than JDBC, the third party, so they develop many database framework. Yeah. So there is one framework called Hibernate. Yeah. In Hibernate, it uses a special way to handle transaction. Yeah. So it uses a way it puts all the queries in transaction. Okay. Yeah. So it uses this way. Yeah. Even if there is one database query, one query, Hibernate still put that one query in a transaction. Okay. Yeah. I think they have their consideration. So they always use transaction way to run the database queries. Yeah. Even if you only have one query, because based on our understanding, if you only have one query, it cannot be separated, right? Yeah. What's the point? You put it in a transaction. Yeah. So they may have their justification. Okay. So they feel at the beginning you only have one query, right? Yeah. Because when your business evolves, that one query could grow to multiple queries, right? Yeah. So they consider, the long-term effect. Okay? Yeah. At the beginning, you only have one query, but you may add some more work in your business task. Then you have more than one queries. Quickly, you will have more than one queries. So then you really need a transaction to protect your data. business data. Okay, all right, yeah. So here, that's the some background. Yeah, properties. This transaction has some important properties. Yeah, the first property, isolation. Yeah, isolation. So that is no interference from other transactions. Yeah, because in one DBMS, it's very common multiple transactions are executed at the same time, right? Yeah, because your DBMs, provide services to many users concurrently. Yeah, yeah. So it's very common. So multiple transactions are executed at the same time. So you want isolation. Okay. Yeah. Yeah. No interference. Yeah. Yeah. Then the second property, I already explained, but the terminology is called atomicity. Atomicity problem. So you cannot separate. Yeah. So the meaning, you cannot separate. So all or none database operations are. So you have only two options. Yeah. Either or, that means you execute all the queries defined in your transaction or none. Yeah. Yeah. You cannot execute part of the queries in your transaction. Okay, so that's all or none. Yeah. Only these two options. Yeah. So people call it atomicity. Yeah. Yeah. Why atomicity? In ancient time, people treat the atom. Yeah, atom cannot be separated. Yeah. Although we know in current science, we know even atom can be separated. Yeah. But at that time, ancient time, yeah, people, for quite some time, people feel that atom is the smallest particle that can never be separated. Yeah. With that understanding for a long time. Yeah. Yeah. But here, so people just use the abstract meaning of that atom. Okay, abstract meaning, that's the non-separability. Okay, yeah, atomicity, the second property. Yeah. All right. The second advanced feature, it's called concurrency control. Yeah. Another important feature. Yeah, concurrency control. Yeah, you can understand the meaning. Many database queries can be executed concurrently. Okay, concurrency control feature. Yeah, so several users trying to update the same data do so in a controlled manner. Okay, yeah. So the multi-threading. So here yeah, because the multi-threading way is used to protect the data. Okay, so you want to because when a DBMS needs to execute multiple queries at the same time, how can you guarantee all these queries are executed correctly, right? Yeah, because you may messed up, right? Yeah. So there must be some internal mechanism to set appropriate order for execution. Okay, appropriate order for execution. Yeah. Yeah. So that's the concurrency control feature must be provided for a typical modern DBMS. Yeah. All right. Yeah. Otherwise, the DBMS may not be very useful. Okay. So if it does not support concurrent, it's not very useful. Here there is an example. Yeah. Actually, I had some experience. Yeah. So I talked to my students, my friends. Yeah. I got this kind of experience related to the concurrency control problem. Okay. Yeah. So that is Microsoft Access. Inside Microsoft Office, there is a small DBMS. Okay. Small business called Access. Yeah. Yeah. So many family business. Yeah. So very small family business. Yeah. Use this Access DBMS to manage their small business data. Yeah. But although Microsoft they designed this DBMS for very small business, typically family home business, small home business, yeah, not for relatively larger business, yeah, but some middle, not that small companies, they use Access to manage their business data. Now, that happened. Yeah. Some company they have hundreds of users in that level. Okay, hundreds of users in that level. Yeah, they still use this Access to, support their everyday database queries, transactions. Yeah. But then there is this concurrency control problem. Okay? Because the older version, yeah, so this is the current version. Yeah. Here I put it, this is the current version. Okay? Current version. But the older version, 10-something years ago, that older version, it does not support concurrency control. Okay? Older version support every time only support one user. Okay? One user a time. Okay? Yeah. Yeah. If multiple users need to access the same web application, they must be queued. Okay? Yeah. Wait in line, in a queue. Okay? One after another to get a service. Okay? Must be queued. So in that way, then the users of the web application notice significant delay. Yeah, they need to wait a long time. Okay, yeah, because when you think about when you have dozens of people, yeah, not too big, even dozens of people, waiting in the queue, to get a service one by one, still you can notice the significant delay. Okay, significant delay. Yeah, so that's the problem, because the main reason is because that simple small Access is a simple small DBMS. It's not a powerful DBMS, so it does not have that concurrency control feature. Yeah, older version. So then the newer version so improve it. Right? So they support 255 concurrent users, much better. So there, those relatively small companies, it's good enough, because it's rare they have more users than 255 use their web application concurrently. It's very rare. Okay, yeah. They usually, most of the time, they do not have that many users. Yeah. So then suddenly their web applications works. The performance is acceptable. Okay. Yeah, no significant waiting time. Yeah. Yeah. All right, so that's the some real world experience. Yeah. All right. Yeah. So then all web applications require this feature for data accesses. Yeah. Yeah. MySQL, yeah. So that's the reason MySQL is so popular in many small, middle-sized, even large-size. Yeah, so there are many large-size company, top level. They may also use the MySQL. Okay, yeah, yeah. Some top level like Google, Facebook, that level, at least some places they use MySQL. Yeah, so that means MySQL is very powerful. Yeah, it can handle large amount of data. Yeah, all right. The transaction feature required. Yeah, so the transaction feature must be built on top of this concurrency control feature. Yeah. Yeah. So if you do not have a concurrency control feature, then you cannot implement the transaction feature. Yeah. So yeah, yeah, they are closely related. Yeah, like this. Yeah. All right. Then the third advanced feature called a stored procedure. This is another important functionality. Yeah. So that the DBMS must have. Yeah. Because if you can, the stored procedure, actually that's the, you can treat it as SQL programming. You can use SQL to write programs. Okay. Yeah, SQL programming. Yeah. Yeah. Procedure here refers to, function. Okay. So you can use SQL language to write definitions of functions to do data processing. That's simple. Okay. Yeah. So people call it stored procedure. Yeah. Where to store? You store somewhere, right? Where to store? Store inside the DBMS. Okay. Yeah. These procedures are created and stored inside the DBMS. Yeah. So let me, explain the details of this advanced feature. Yeah. In form of functions with input and output. Okay. Yeah. So you just like regular functions, right? Yeah. So you need to provide input, and sometimes you may have output, and sometimes you may not have output. Okay. Yeah. Just like void function, you only do data processing, and your function does not return any output data. Yeah. Yeah. All right. Written in SQL. Yeah. SQL statement. Yeah. SQL has the logic, if, else, the logic, control, yeah. So you can use SQL to write a program, yeah. Function, definition of the data processing functions. Yeah. All right. Execute a sequence of SQL statements in DBMS. Yeah. So DBMS just compile. Yeah. Just treat it as a typical program. DBMS needs to compile your one stored procedure into executable machine code, right? Yeah. So then it just call the function. When you use it, it calls this function. Okay. Yeah. And it belongs to part of the database definition, and people also call it metadata. Yeah, let me explain. Yeah. Database definition. Actually, later in our 8.2, we will learn more about this database definition, this metadata part. Okay. Yeah. That database definition. I give you the first database in this class, AnimalDB.SQL. In that one, we have table definition, right? Yeah. So that's those SQL statements that you use to define your database constructs. Yeah. The constructs. Yeah. So table definition. Other than table definition, you have you can define other things, constraints, domains, many other things you can define. Yeah. So we treat that part, the database definition part. Okay. Yeah. And the people also call the data that belong to the database definition, people call it metadata. Metadata means, metadata means the descriptive data. Yeah. The, literal meaning of this metadata, that's the descriptive data. The data you use to describe other data. Okay? Yeah. Yeah. So that's the the meaning of this metadata, descriptive data. All right. Can be called locally and remotely from application programmers. Locally, yeah, because you work on the same machine that runs database server. Yeah. So then you just call some stored procedures directly. Okay? Yeah. So the syntax is very easy. You just type call command. Call, then you just, each procedure, the function, you have a name, right? Okay? Each function, each procedure, you have a name. You just call that name. Okay? Yeah. On the same machine of your DBMS. Yeah. So at the command window. Yeah. So you can find the appropriate command window. So then you type this command. Okay? All right. That's the local. Call it locally. But another way is remotely. Yeah. You're not working on the same machine. Yeah. Yeah. You want to access a remote database, through URL, right? Yeah, through appropriate URL. So you can access remote database. Yeah. But when you access remote database, you can send this command, call the procedure, this command. You can send it to the remote database. So you call, you ask that DBMS to execute this stored procedure. Yeah, that's remotely. Okay. Yeah, from application program. Yeah, because how do you call? Your role, you as a web application developer. So in your application program, so you write the SQL statement. Yeah. So you know how to execute a SQL statement. Yeah. So when you execute a SQL statement, you just send this call, yeah, because this is a SQL, right? Yeah, this is SQL command. You just send the SQL command to the remote database server. So you call it, okay? Yeah. All right. Can be created in application program. Yeah. So you can even create it in application. How? Because you can send a sequence of SQL statements to the remote server, right? Yeah. When you send a sequence of SQL statements, you can send all the SQL statements used to define a stored procedure to it. Okay? Yeah. Yeah. So you can create, all the SQL statements you can send one by one to the remote server. Yeah. After DBMS receives all these SQL statements, yeah. So it puts it together, put them together, yeah. So then you can get a stored procedure, yeah. All right. Can reduce data traffic on internet. Yeah, that's another important advantage. Yeah. So why? So this is some benefit. Yeah, reduce. This is one of the benefit using this stored procedure. Reduce data traffic on internet. Okay. Yeah. Yeah. Because we know where a web application is deployed on many web servers in the world. So many of those servers, they are located in different locations, different countries, different geometric locations. So a lot of data traffic, and this store procedure can reduce a lot of data traffic. So how to do it? I may like to delay sometime later. So when I talk about other concepts, so I will further explain how to reduce the data traffic. I want to work because later when I explain another feature and a concept, so I just combine with that one and explain once. It explains this property once. All right. So here we have a question mark we need to answer at a later time. Okay. That's about how to reduce the traffic. Okay. I need to spend quite some time to explain, probably 20 minutes to explain. The whole thing. Whole idea. All right. So improve performance. All right. And another usage, enforce business rules. That's another. So this point we will talk about this many times. Business rules. Because some business rules could be very complicated. Some business rules could be very complicated. How do you check when the business data is entered? Sometimes you need to check if the data follows certain business rules, right? And most of the time, people do not want human to do the manual check. Okay, it's a tedious, error-prone, right? So the best way is use program to check the data, given data against the business rules. So the best way to do that is write some stored procedures to do that. Because stored procedure, you can, inside one stored procedure, you can check some very sophisticated business rule. Okay, you have logic, you can use the control logic to check if the business rules, certain business rules are followed. So that's another important situation to use the stored procedures. All right. So let's look at 8.2, basic database concept. After we learn these three advanced features, some relatively simple basic concepts we also need to know related to the database and the DBMS. All right. Define a database. How to specify a database. At this point, we have some idea, right? Because we saw some simple example. So we have some ideas. So we need to, describe the structures. Structure, usually table. The table design. How do you design your database tables? That's the basic structure. Okay, basic structure of your tables. All right. Then data types. You need to choose appropriate data types. And the constraints of data. So in module 3, we will study the details of constraint of the, because the data, you need to set certain constraints. Okay? Yeah. Constraints of different types. Yeah. And we can use SQL to specify the constraints, to define, those constraints, domain. So the data, for example, the data should fall in certain range, right? Yeah. For example, the department number, right? Yeah. So in our company database, there is a department table. Department table in the company database, okay? In our company database, okay? Yeah. But think about when people enter a new employee's information. Yeah. When a new employee data is entered, you need to specify the department number, right? Yeah. This employee is in one of the 6 departments. Yeah. So in that this database, so there are 6 departments. So department 1, 2, 3, 4, 5, 6 department. Okay, so that means department number should be in one of these 6 numbers. Yeah. So if you get a number outside of these 6 numbers, it's not a valid department number, right? Yeah. So you may need to define a constraint, to describe the valid department number. Okay, yeah. So that as a simple example, yeah. All right. Metadata, yeah. So we talk about this metadata. So that's the descriptive data for data. Yeah. So this is our main data. So this is our main data, or this data, that's the business data. Okay. That's the real business data. Yeah. But you need some supporting data, right? So other than the business data, yeah, you need some supporting data. Supporting data. Okay? Yeah. Now some extra data used to support the management of the business data. Okay, yeah, management. Yeah, so that's why this business data people also call treat as the primary data. Primary data, and this part as secondary data. Because the role is supporting role. The secondary plays the supporting role. That's the metadata part. Okay? All right. Refers to database definition stored by the DBMS in the form of database catalog or dictionary. So there is another concept called a catalog concept, database catalog, and another name for it called dictionary. Yeah. So you have, because how to access the business data in the right way, right? Yeah. How to, so the DBMS needs some special way to organize the business data. Yeah. So, so there is a special place to store the metadata things in this catalog. Okay, yeah. Dictionary catalog. Yeah. All right. Yeah, so we can use a diagram to see it. Okay, yeah. This graph, this diagram, you can see the relationship. Yeah. Oh, sorry. All right, here. Yeah, so you can see users, programmers. So we are users. We are programmers here. Okay. Yeah. We treat ourselves as the programmers. All right. So then database system. So what's the database system? The database system contains DBMS software. Okay. Yeah, that's gray box. But it also contains the data part. Yeah. Data part together with this DBMS. Yeah. Yeah. And this level application programs queries, yeah. So you have this database system. Yeah. All right. DBMS. Then you have these two blocks. Okay. Software to process query programs. Yeah. Then lower level, yeah, closer to the data, software to access, store the data. Yeah. But the data split into two parts. See? Two separate locations. One, the stored databases, that's the business data. That's the primary part. Okay, that's the primary, the business data. Yeah. This is metadata and the secondary data. Okay, yeah, secondary data. Yeah, and this part, we call the catalog. A dictionary, yeah, to organize, to help us do the bookkeeping. Yeah. Right. All right. So database system. All right. Then application programs of databases. Yeah. Now we need to look at. So still. We as application programmers, we need to write application programs and to do database queries. Yeah. So here, let's look from that point of view. Yeah. So when we develop application programs, what we can do in our programs. Yeah. All right. An application program accesses the database by sending queries to the DBMS. Yeah. Remember? Yeah. So a few lectures ago, I mentioned two interfaces, right? Yeah. One set of interfaces for application programmers. Another set of interfaces is for DBA, yeah, DBA, administrative people, yeah. So here, we only consider the interface that we need to use. That's the, programming interface. I need to erase interfaces. Okay, yeah, because you may have multiple interfaces. All right. Yeah. Through the programming interfaces, you can send queries to DBMS. For example, we can use Java JDBC. Yeah, the example is the Java JDBC. Okay, in Java JDBC, you can see a set of interfaces you need to use to do the typical database query. Okay. JDBC refers to Java database connectivity. All right. Yeah, but PHP also has a special way. PHP doing the database queries through a set of functions. A set of functions. Different from Java, okay? Yeah. A set of functions, and these functions related to the DBMS. These functions are related to DBMS. It's different from Java. Java does not use this way, okay? Yeah, at some time I will compare these two ways. Yeah, but here I do not have enough time, so I cannot compare PHP way and the Java JDBC way. Yeah. All right. Yeah. What people can do, create database. Yeah. Create database, just a SQL command, right? Yeah. Create database, then you specify your database name after those two keywords. Okay. Create a table. Yeah. Just a standard create table statement. Yeah. You can send it to the DBMS. Yeah. Create a store procedure. So you need to send a sequence of SQL statements. Yeah. Call a store procedure. Yeah. You send a call, the name of the procedure, yeah, to the DBMS. Yeah. All right. Do other regular queries. Yeah. So, through certain way. Yeah, through certain way. So Java, through programming interface. Or PHP, yeah, because the interface is built in these functions. Okay. Yeah. Those functions already, take care of the, interface part. You just call appropriate functions. Yeah. 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 The PHP way. Yeah. All right, I run out of time. Yeah, but I pretty much I finished this slide. So this is the last slide. Okay. Yeah. Yeah. All right. So here I said, but you have the capability to do these things. Yeah. But to do it, it's a important big business decision. So it's not a technically you can do it. Yeah. But you need to have some business consideration to really to do these things. Yeah. All right. Yeah. So we finished everything in this part A. Yeah. So next time we can start part B. Yeah. All right. Yeah. So let's stop.